and welcome. Introducing a new graphing calculator. And here it is. It plots cubic, quadratic, and cubic functions. This here is a cubic, 1x squared plus 1x cubed plus 1x squared plus x plus a constant plus 1 plus 1x plus 1. And here's the graph. There's the graph, and it goes from on the domain, it's going from 0 to 1, plus and minus 1, and on the range, it's going from 0 to 4. And here is where you adjust it. The domain is going from 0 for 1. Let's make it go to 2. Now we got a bit more of the curve, and we can see how far down it goes, and the drop here was hidden at the default setting. Here's the default setting, and we don't see that. We just see a little bit of this wave, this little S wave, and if we increase the domain, then we see that it drops at about 1.8, and on this side at about 1.1. And the y-intercept, it's crossing the y at about 2, 4, 6, 8, 1. Obviously it's 1. If you go to the equation, you sub in 0, 0, 0, and you just get the d, and the d is at 1. So let's move it up a bit. There we go. The y-intercepts, the whole thing's moving up. Let's bring it down. And we can bring it down. Okay, so that's 1x cubed plus 1x squared plus 1x plus 1. And now let's look at some other functions. Here we have a parabola offset by I guess 4 or 3, I'm not sure off the top of my head which way offsets it on the x, but let's plot it. So we go to the graphing calculator, and we sub in 0 here. We don't want the x cubed term, so we just sub in 0 here, and it's x squared minus 4, so we put in here minus 4, and minus 4 plus 3. And so for the d term coefficient, constant coefficient, we'll put in 3, hit enter, and there we have our graph. Let's see, and let's increase the x range, x domain. It's only going up to 3, so we don't see the right side of it, so increase the x domain, and there we go. Now we have the full graph in view. And let's increase the y domain a bit, or decrease it. And there we go. We'll set this to 0.5, 0.3. Okay, and here we can see 1.8, 1, 1.8, 2. Right about 2 is the inflection, or the changes in direction around there. Right here we can see it crosses the x-intercept at 1 and 3, and we see we have this one here hitting it at 3 on the dot, and right here we can see it goes crosses at about 1, and the y-intercept here is about 2.7, and we see here the y-intercept 2, 2.4, 2.5, 2.6. Oh wait, 2.2, 2.2, 4, 6, 8, 1, 1.2, 4, 6, 8, 2, 2.2, 4, 6, 8, almost 3. So yeah, this here is crossing at almost 3, just under 3, or pretty much almost exactly 3. Well, we could plug it in the equation and get the exact result, but there we go, we got that parabola. Let's see another function. Well, this one we can't do. This is a complicated one. It's not designed for this one. It has a function on top and bottom. But any of these we could, except for this one. This is to the power of 4. So we can just do the quads and the cubics. So we can do this one, x squared minus 2x plus 1. And x squared, sorry, what was it? X squared minus, no, x cubed minus 2x plus 1. So x cubed, set this one to 0, minus 2x plus 1. And let's see the range and domain now. We want to go from plus and minus 3. So we set the domain to 3. And the range, we want to go for about 10. Plus and minus 10. So set that to 10. And let's put some more divisions so we get more dots. Oh, sorry, more divisions so we get more dots. There we go. Too many. That's good enough. There we go. We have our graph there. And let's see this one here. So around here it's just under 1 hits there. This is about 2. Here it's about minus 1.55, minus 1.55. Here minus 1.55 here. This one here is about 1. So what do we got here? It's about here. This is about just after 0.8, between 0.8 and 1. It's going, oh wait, it's under 0.8. It's around 0.7. Let's see, the y-intercept is not showing. We gotta get some numbers here. So increase, decrease. Oops, not that one. Decrease this one a bit. So we get some lines. Too many. 0.1. Make this 0.2. Okay. And we see it's crossing the y at about 1. So what do we got here? It's crossing the y. Well, they don't put any numbers. Okay, so there's that one. Let's see another one. Oops, it is x squared. Okay, here's another 5x squared. We can see this one. Minus 2x plus 2 1/3. 5x. We can reset to the original one. 1x cubed plus 1x squared plus 1x plus 1. That's the original. And the range and domain, everything gets reset. Okay, so here we're going to do 5x squared minus 2x. So set this to 0. And 5 minus 2 plus 2/3. And there we have it. And let's see the domain and range. We're going to zoom it out a bit. So we want to go from about plus and minus 6 and 120. So plus and minus 6 and 120. Let's see if it works. Plus and minus 6. So the domain 6 and the range 120. And we're going too much here, so put that to 10. And there we have it. So let's look at that. Let's make it even bigger so we can see a bit higher. 150. And this X, we got too many on the X. We don't need so many. So we'll put that. Oh, we want more data. Make this 0.3. And so we got a parabola, and it's almost centered at 0. Looks like a little bit over. Let's see what we have. It's centered at about 0.5 here. And that's it. That's the parabola. That's all the functions in the textbook that we can compare to. We saw this one already. Oh, here's some more. No, they don't give the function. Okay, here's another one. X cubed minus x squared minus 2x plus 2. X cubed minus x squared minus 2x plus 2 plus 2. Okay, and it's another one of those S ones, and we want to go from 3 and we want to go to 4 on the range. 3 on the domain and 4 on the range. 3 and 4. Now our divisions are got to be smaller than the range, so I'll put this at 0.2. And we want more data, so let's make this one small. So we get more dots. The divisions dictate the number of dots. Maybe in the future I will separate it into a resolution button, but for now, the way I coded it, the divisions dictates it. So there we have our graph there, and we get about, it crosses at 1, just like crosses at 1, and it dips at the most at 1.2, and then it crosses again at about 1.4, and here it crosses, the y-intercept is at about 2, and here we got minus 1.4, about 1.4, a little bit over. Okay, let's see. That's about it. That's good enough. So it's a graphing calculator. It's free. You can go to my website and use it. I'm gonna have it posted at the domain, at the URL quad-cube-plot, and that means it plots quadratics or cubics or cubic functions. If you want it to be quadratic, just set the cubic term, this one, to 0, and then you got a quadratic. That's about it. Thanks for watching. I hope you like it. It's a great tool for doing graphics. You can works on your phone. It should work on the phone. I tested it, but not fully. But as far as I know, it works perfect on the phone, and it's a great learning tool for learning math. And also, if you view the source code is not obfuscated or filibustered. It's very brief. It's very concise. Only what you need. It's very simple. Only what you need is there. There's no dependencies. And here you have it. Simple function. Just multiply them. CFA times the function x times x 3 times. Coefficient b times f times x 2 times. Coefficient c times x once. And then the third one. The fourth one, d. And so that's all it takes to do it in the computer, to code that function in the computer, and to do the SVG. Here's the SVG coding, setting up the SVG document. It's a SVG plotter, so the dimensions, everything, engineering level, correct at an engineering level. And this maps between the plot we have and the actual screen. So the plot we have here, it's centered here, and we're setting the limits 3 and 4 for the x and y, But the actual document, SVG documents, go from the top left corner, 0, 0, and then go to the window screen. Window.inner width is this point right here, and then inner height comes up, or y comes positive down. So that function there that I mentioned over here, that just does that mapping. Window.inner width, window.inner height, and the zoom is our uh, 4, 3 and 4 over that width. And what else is in the code if you wanted to learn how to make something like this? You're not going to find anything easier. Oh, here's a depiction, diagram of the mapping. So that should be easy to pick up. And here's the draw. This draws the axes and those tick marks. Very straightforward. And this one, as I mentioned, plots it. There's the equation, and here's the SVG plotter. Just loops over the points, calculates it, plugs in, see here, calculate. That just calculates that into this function here. That just runs this code. Here's the calculate function, and then it plots it on the screen. Then it uses that mapping function, so the function calculation maps to the screen. There we go. And then for the UI programming, you're gonna need to look at the form. Here is the form, and there we go. We have a reset. When you click reset, and when you click change, any change happens, and it just copies the form data from that form into a data property, which is, you don't really need to do it. That's redundant, but I like to do that. It's redundant because you already have it already there. Document forms, you can just use document forms, but I just copied it over, and even though you put number in your HTML, here if you look at the HTML, even though you put here type number, when you read that property, you still need to convert it to an actual number, otherwise it's a string. So that's a little tidbit about learning how to program forms in the browser. And mostly here you can do lots of graphs. It's a graphing calculator. It works. It's free. It works on your phone. It might be the best one. I never tried the other ones. As far as making it better, like I mentioned, separate that zoom. Here right now the zoom is tied to the number of X divisions. So if I could separate that, that would be great, so you don't have to, because sometimes you add too much resolution, then you get too many of these location annotations, and then it gets all a little messy. So you might want to set this low so you don't need so many annotations, but also get lots of dots. So separate that would be great. Another option would be to make things better would be like if the center point could move. So that would be a great next step. And also the data table itself, I was thinking I would print that down in the footer. Every time see all these data points that have been calculated, they're in memory anyways, so might as well drop it in here in a table. So that would be a great one. And that's about it. Those few additions, it would be much better, but it's still plenty good, and it does the job. So give it a try. Hope you like it. Thanks for watching, and have a great day. Bye bye.